overview and objectives. Children, you all would be familiar with the term reflection. But have you ever heard of terms like refraction and dispersion of light? Today, let's learn these concepts in detail and where they come into use.
Wow! What a wonderful rainbow! But why do rainbows come only when it rains? And how are they formed?
Let me explain you.
Learning objectives. In this topic, we will learn about refraction of light, dispersion of light, refraction. The change of direction of light because of change of medium is known as refraction or refraction of light. The ray of light changes its direction or phenomenon of refraction takes place because of difference in speed of light as it enters from one transparent medium to another. The cause of refraction is the change in the speed of light as it goes from one medium to another medium. When ray of light enters from a rarer medium, that is gas, into a denser medium, that is liquid, it bends towards normal at the point of incidence. Also, the angle of incidence is greater than the angle of refraction. On the contrary, when ray of light enters into a rarer medium from a denser medium, it bends away from the normal. Also, the angle of incidence is less than the angle of refraction. Ray emerging after the denser medium goes in the same direction and parallel to the incident ray. The angle between incident ray and normal is called angle of incidence, and it is denoted as I. The angle between refracted ray and normal is called the angle of refraction. Angle of refraction is denoted by R. The phenomenon of change in path of light in going from one medium to another is called refraction of light. Laws of refraction. A. The first law of refraction. The incident ray, the refracted ray, and the normal at the point of incidence all lie in the same plane. B. Second law of refraction. The ratio of sine of angle of incidence in the first medium to the sine of angle of refraction in the second medium is always constant for a given pair of medium and for a given wavelength of light. That is, sine I divided by sine R is equal to constant, where a constant n is known as refractive index of the second medium with respect to the first medium. This law is also called the Snell's law. The constant is called refractive index of the second medium in relation to the first medium. The ratio of speed of light in vacuum to the speed of light in a medium is called the refractive index of the medium. It has no unit. Refractive index. The value of the refractive index for a given pair of media depends upon the speed of light in the two media. Refractive index of medium 2 with respect to medium 1 is equal to V1 divided by V2, where V1 is the velocity of light in medium 1 and V2 is the velocity of light in medium 2. Similarly, refractive index of medium 1 with respect to medium 2 is equal to V2 divided by V1. The value of the refractive index for a given pair of media depends upon the speed of light in the two media, as given below. Speed of light in air is equal to c. Speed of light in a medium is equal to v. Then refractive index of medium, Nm is equal to c divided by v. Refractive index is the relative value of the speed of light of a medium with respect to the speed of light in vacuum. Thus, light will travel faster in the medium having lower value of refractive index. Refraction of ray of light through convex and concave lenses. A. Refraction of parallel ray. A parallel ray converges at focus of a convex lens and diverges from the focus of a concave lens. B. Refraction of ray passing through the principal focus. A ray passing through principal focus emerges parallel to the principal axis after refraction from a convex lens. A ray passing through the principal focus emerges parallel to the principal axis after diverging from a concave lens. C. Ray passing through the optical center of lens. Ray passing through the optical center of convex and concave lens emerges in the same direction without any deviation. Refraction of light through a prism. Prism is a transparent optical element which refracts light. An optical object to be defined as prism must have at least two faces with an angle between them. Triangular prism is the most common type of prism. It has a triangular base and rectangular sides. When a ray of light passes through a glass prism, it gets bent twice at the air-glass interface and glass-air interface. Example: if KL be a monochromatic light falling on the side AB, it gets refracted and travels along LM. It once again suffers a refraction at M and emerges out along MN. The angle through which the emergent ray deviates from the direction of incident ray is called angle of deviation, D. The angle between the surfaces of the prism is called the angle of prism. Angle A between the two refracting surfaces ABQP and APRC is called the angle of prism. Dispersion of white light by a glass prism. The phenomenon of splitting of white light into its component colors is called dispersion of light. It takes place because of the angles of refraction of light for different colors are different. The dispersion of white light occurs because colors of white light travel at different speeds through the glass prism. The amount of refraction depends on the speed of colored light in glass. Since different colors travel at different speeds, they are refracted by different angles on passing through the glass prism. So, when white light consisting of 7 colors fall on a glass prism, each color in it is refracted by a different angle, with the result that 7 colors will spread out to form a spectrum. The band of 7 colors formed on a white screen when a beam of white light is passed through a glass prism is called spectrum of white light. The 7 colors of the spectrum are violet, indigo, blue, green, yellow, orange, and red. That is Vibgyor. Newton's experiment. When a beam of white light is passed through a glass prism, it is split up into its component colors. When these colors are allowed to fall on an inverted glass prism, it recombines to produce white light. Natural spectrum, formation of rainbow. A rainbow is a natural spectrum appearing in the sky after a rain shower. It is caused by the dispersion of sunlight by water droplets present in the atmosphere. The water droplets act like small prisms. They refract and disperse the sunlight, then reflect it internally and finally refracts it again when it comes out of the raindrop. Due to the dispersion of sunlight and internal reflection by the water droplets, rainbow is formed against the backdrop of sky. A rainbow always forms in the direction opposite to the sun. The essential condition for observing a rainbow is that the observer must stand with his back towards the sun. Atmospheric refraction. When light enters from one medium to another, there is a deviation in its path. This phenomenon is called refraction of light. Atmosphere is composed of layers of various optical densities. Because of this, light rays passing through various layers of atmosphere get deviated. Many interesting phenomena can be observed because of atmospheric refraction. Some of them are given here. Twinkling of stars, advanced sunrise and delayed sunset, scattering effect. Another important natural phenomenon where we encounter atmospheric refraction is scattering of light. When light hits a particle, it scatters in different directions. Refraction happens because of non-uniformities of particles of a medium. Many interesting phenomena can be observed because of scattering of light. Some of them are given here. Tyndall effect. The color of clear sky is blue. Tyndall effect. The Earth's atmosphere is a heterogeneous mixture of minute particles. These particles include smoke, tiny water droplets, suspended particles of dust, and molecules of air. When a beam of light strikes such fine particles, the path of the beam becomes visible. The light reaches us after being reflected diffusively by these particles. The phenomenon of scattering of light by the colloidal particles gives rise to Tyndall effect. It is named after the 19th century physicist John Tyndall. Tyndall discovered that when a strong beam of white light is passed through a colloidal solution, light is scattered by the colloidal particles. This scattering of light is called the Tyndall effect. The illuminated beam or cone formed by the scattering of light is called Tyndall beam or Tyndall cone. The path of the light becomes visible when viewed from a direction at right angle to that of the incident light. This phenomenon is seen when a fine beam of sunlight enters a smoke-filled room through a small hole. Thus, scattering of light makes the particles visible. Tyndall effect can also be observed when sunlight passes through a canopy of a dense forest. Here, tiny water droplets in the mist scatter light. The color of the scattered light depends on the size of the scattering particles. Very fine particles scatter mainly blue light, while particles of larger size scatter light of longer wavelengths. If the size of the scattering particles is large enough, then the scattered light may even appear white. Summary.
So, have you understood the concept behind the formation of rainbow?
Sure, Mom. Thank you very much for clarifying my doubts.
Children, we have thus come to an end of our discussion on this topic. Hope you have understood the concept of refraction and dispersion of light. Summary. In this topic, we have learnt about refraction of light, dispersion of light,